Hi everyone, so let us start with our next topic of your chemical kinetics, that is your molecularity. The topic name is molecularity. Now what is the definition of molecularity? Molecularity means the number of molecules or atoms that take part in chemical reaction. Now here you have a twist, okay? Molecularity, as the name suggests, the number of molecules or atoms which take part in a chemical reaction. Number of molecules or atoms which take part in not a chemical reaction, but here you will write elementary or your single step chemical reaction. This is very important, okay? Elementary or single step, this is very important. What is it telling you? Number of molecules or atoms which take part only in a single step. So molecularity is only defined for those reactions which have a single step reaction. Okay. Next was, now what is elementary reaction? So this concept is particularly only for single step reaction. Only for single step reaction. Okay. Now what is an example of single step reaction? Some examples of your elementary or single step reaction I'll give you. Elementary or your single step reaction my first example, A plus B is giving me C. Now they are already mentioning that it is an elementary reaction. What does elementary reaction means? It is a single step reaction. Experimentally they are telling your rate to be K, A raised to the power 1 and B raised to the power 1. So what is your order of the reaction? The order of reaction will be 2, and what will be the molecularity of the reaction? 2 molecules are taking part, right? So molecularity will also be 2. Second example. If I tell you NH4NO2 is giving me N2 plus 2 H2O, and they are already mentioning to you that it is an elementary reaction, and by experiment your rate equals to K NH4 NO2 raised to the power 1. What is the order of the reaction? 1. What is the molecularity of the reaction? 1, right? So in both these cases your order as well as molecularity will be equal to your 2 or 1, like same, order and molecularity are same. Next example, let us see more examples of elementary reaction. 12:30. The reaction is 2HI is giving me H2 plus 2I2 plus I2, and they are mentioning to us that it is an elementary reaction. What does elementary means? It happens in a single step. So what will be rate equals to KHI raised to the power 2. What will be the molecularity? Molecularity will be equal to your 2, your order will be equal to your 2. The next reaction, 2NO plus your O2 is giving me 2NO2. This is also single step or elementary reaction. So here also your rate is equal to your KNO raised to the power 2, O2 raised to the power 1. So here also your order is equal to your 3, and your molecularity is equal to your 3. So this is like termolecular. Whenever 3 molecules are taking part, it is called termolecular. Here it is called as bimolecular. Okay. Now next example, very important example. Next example is CH3COOC2H5 plus H2O is giving you CH3COOH and C2H5OH. Now they are telling you that this is also an elementary reaction. What does elementary reaction means? It means reaction is happening in a single step. Now here your rate equals to your K, CH3COOC2H5 raised to the power 1, and if I want to write my rate, logically this should be written as this, right? But you have to be careful here. Why? Here you can see water is present here, right? Water is present. So water is the solvent, right? Means it is freely available. It is in excess. Water is present. It is freely available, and this particular thing is in excess. Like for example, if I take 100 moles, like 100 molecules of water are present, 1 molecule of CH3COC2H5 is present. So means water is reacting, you are getting 99, like very negligible effect on water's concentration, like no effect, right? So this particular thing, this particular concentration, we regard it as constant. We define it as constant value because this concentration is not at all changing. This concentration is kind of constant. Okay, so here instead of this rate we'll write R equals to K CH3COO C2H5 raised to the power 1. So here your order and molecularity will not be same. My order is 1 and my molecularity will be equal to your 2. So this particular example is an example of your pseudo first order, like false first order reaction. Pseudo first order reaction. Okay, pseudo first order reaction. More example from this will take is inversion of cane sugar. Pseudo first order reaction, more example is inversion of cane sugar. Inversion of cane sugar. So what is the example? C12H22O11 plus H2O is giving you glucose plus fructose, C6H12O6 plus your C6H12O6. So here also water is present as solvent, it is present in excess, so my rate will be equals to just C12H22O11 raised to the power 1. So my order will be equal to your 1 and my molecularity will be equal to your 2. Okay, this is also an example of pseudo first order reaction. Similarly, you can get pseudo second order reaction also. If I tell you 2A plus B and I am mentioning that this is present in excess, is giving me C. What will be my rate equal to? A raised to the power 2. So my molecularity will be equal to my 3, but my order will be equal to 2. So this is an example of my pseudo second order reaction. Pseudo second order reaction. Okay, one more example, just write on your own. X plus Y is giving me Z. It's an elementary reaction. What will be the order and molecularity? This is your question for homework, just write on your own. Rate will be equal to what? Molecularity will be equal to what? And your order will be equal to what? This you need to solve it. Okay, so now you know molecularity is only for simple order reaction, elementary reactions, right? What happens in complex reactions? Like, what is complex reaction? Multi-step reactions. Complex or multi-step reaction. For example, NO2 plus CO is giving me NO plus CO2. Now they have mentioned that this is a complex reaction. So here my rate is NO2 raised to the power 2. This is determined experimentally, obviously, right? Here my order will be equal to 2, but what happens to molecularity? We studied that molecularity is only defined for your elementary reaction. So here in complex reactions, molecularity is not defined. Molecularity is not defined. Next example. CH3CHO is giving me CH4 plus CO, and this is a complex reaction. They are mentioning us that this is also a complex reaction. Here my rate equals to KCH3CHO, like this is defined experimentally 3 by 2. Here my order will be equal to 3 by 2, and what will be molecularity? Molecularity will be not defined, like not defined, not 0, not defined. We'll write not defined. Okay, there is a small topic here also, like small introduction I'll give you of the topic, that is collision theory. Collision theory. What is collision theory actually? Reactant molecules, your reactant molecules collide effectively. The reactant molecules, what are they doing? They are colliding effectively to give the products. See, how does a chemical reaction happens? By the collision of atoms, collision of molecules, right? Now there might be some collisions which we don't care about, which are not effective, which are not giving us the product. We don't care about those collisions. So this is what your collision theory is telling. Reactant molecule, some molecules effectively gives collision and some molecules don't give collision, don't give effective collisions. Okay, so whenever your molecularity is less than or equal to 3, means the probability of simultaneous and effective collision, the probability of your simultaneous and effective collision of 3 molecules, the probability of 3 molecule colliding is very low, hence your intermolecular of high molecularity, higher molecularity reaction is rarely observed. Like for example, if you have this reaction N2 plus 3H2 giving you 2NH, you might feel that the molecularity is 4, but no, this is not 4. This maximum only 3 molecules can collide with each other. Okay, so this is about your molecularity and order of reaction. Next is, let us write the difference between order of the reaction and molecularity. Order of reaction and molecularity. Now you know order of the reaction is experimentally determined, right? The first point will be order of reaction is experimentally determined. Molecularity of the reaction theoretically determined, right? Theoretically determined. The second thing is, it is defined, order of the reaction is both for elementary reactions also and for complex reactions also. Whereas molecularity, you know, is just for elementary reactions. What about the order? The order can be positive, it can be negative, as well as it can be zero. Molecularity can never be negative, like it's always integer, always positive, because you cannot have negative molecules, you cannot have half molecules, right? Next is order can be greater than 3. Order can be greater than 3. And what about your molecularity? Molecularity can never be greater than 3. Can never be greater than 3. So this is all about your order and molecularity. Next topic which we are going to study is your effect of temperature on your rate of reaction. Okay, that's all for this video. Thank you so much.